Hello again, Southwoods math students. This is Mrs. Lindsay here to bring you part 2 of your video about transformations of parabolas. Today we're going to concentrate on dilations. After this video, you should be able to complete slides 12 to 13. Remember, slides 10 to 13 on your slideshow are due Friday, April 3rd. Please download and type them or print them and take a picture to submit to me by Friday. Please join me on slide 6 of the slideshow that I sent to you on Google Classroom. On slide 6, you notice that we have the parent function of the parabola. So we write as quadratic equation k of x equals x squared. Notice the lead coefficient is positive, so it's concave up. The vertex is at 0, 0, and it grows not at a constant rate, but in a pattern. If you notice from the vertex, if we move over 1, over 1, up 3, over 1, up 5. So the growth is constantly getting larger, but at a pattern of 1, 3, 5, 7. If we had enough room, it would go 9, and etc. Right? So it grows in odd numbers. The dilation will change the growth rate. When the dilation gets larger, the growth rate will get faster or narrower. So the faster the growth, the narrower your parabola will be. If we have slower growth, your parabola will appear to widen. So, what does that mean? Looking at the next slide, we're going to take that parent function, let's call it k of x equals x squared, and we're going to make a new function by multiplying a coefficient of 2 in front of the k of x. The vertex still at 0, 0, still concave up because the lead coefficient is still positive, but what happens to the growth? Well, you can see from the parent function, it starts to grow faster. And the faster growth gives it a narrower appearance. So it tends to narrow, right? So we have faster growth. Which gives the appearance of the parabola narrow. So originally, our k of x grew at a 1, 3, 5 pattern. The j of x is going to grow at a 2, 6, and 10. So it doubles. So it's double growth. And that makes sense because we did multiply the parent function by 2. But more importantly, the parabola gives the appearance of narrowing. So the parabola narrows. So if you see a narrow parabola, you know that the parent function must have been multiplied by a coefficient. Okay, we're going to play with that p of x for a minute. And we're going to play with that j of x for a minute, and we're going to add a constant to it. So if you recall, when we add a constant, like 5, that simply translates it up the y-axis, 5 units. So the shift here is up 5. And if you notice, the vertex changes to, instead of 0, 0, it moves up the y-axis. So it is now 0, 5. And the equation is going to be p of x equals 2x squared, the original j of x, plus 5. Translation, up the y-axis, 5 units. So now what happens if we take p of x and we make it negative? So we need to make the entire function negative. So 2x squared plus 5 all becomes negative. Well, what would happen to the equation? That negative has to actually distribute as a negative 1, so r of x would now become negative 2x squared, but also the positive 5 would change to negative 5. If you notice, the parabola flips over the x-axis, reflects over the x-axis. The vertex actually jumps down below the x-axis. So our new vertex of the reflected parabola is 0, negative 5. What happened? The y-coordinate from positive became negative. Why? Because we had to distribute the negative 1, and it's just like looking in the mirror. So you can see our 3 vertex, 0, 0. When we add 5, it becomes 0, 5. When we reflect it, it becomes 0, negative 5. So let's take a parent function. Let's call it a of x equals x squared. And if a of x equals x squared, remember, vertex still 0, 0, still concave up, lead coefficient is positive. What happens if we make b of x half of a of x? Well, when we made the function twice the parent function, it narrowed. What would happen to the growth if we made it half? Well, you can see here that b of x is actually wider. The parabola shrinks by 1/2. So instead of a growth rate of 1, 3, 5, 7, etc., it's going to be half that. So it'll be 0.5. And it'll be 1.5. And it'll be 2.5. And etc., 3.5. So it'll grow by half. Right? Let's compare that to what would happen if I took c of x and actually tripled the parent function. If we tripled the parent function, we would get c of x, which would actually be a narrower. So c of x is the narrowest, the parent function is in the middle, b of x is the widest. So when the lead coefficient is greater than 1, we know, so if it's greater than 1, we know that our graph is going to be narrower. And if the lead coefficient is smaller than 1, like some type of fraction, the graph is going to widen. Well, you are now able to do the assignments on slides 10 through 13. Please ask me any questions. If you have any problems, they're due by Friday. I will read them and I will comment back to you. Remember, growth mindset. If you get anything wrong, I'll let you know, and you are perfectly welcome to fix that. Okay? So this is Mrs. Lindsay signing off. See you online. Good luck.